The overall goal of this procedure is to simulate the early stages of a core meltdown accident in a nuclear power plant on a laboratory scale, enabling the study of the melting behavior involved in the formation of corium.
This experimental approach helps answer key questions in nuclear power plant accident research. For example, one can determine the temperatures that, depending on the atmosphere, can lead to failure of a core's thermomechanical stability.
The main advantage of this technique is that it is performed remotely, allowing the use of real radioactive materials in the experiment.
Though this method can provide insight into the melting behavior of reactor core materials, it can also be applied to other refractory ceramics, high-temperature superalloys and aerospace coatings.
This is a unique method for studying materials at extremely high temperatures for short times. It is therefore very useful in order to establish thermodynamic equilibrium reference states for the observed material behavior.
First, calibrate the fast 2-channel pyrometer and the spectropyrometer using reference standard lamps. Determine the calibration constants. In a shielded glove box with optical quality windows, mount the sample in a holder with high temperature zirconia glue or graphite, molybdenum, or tungsten screws. Place the sample and holder horizontally in a controlled atmosphere autoclave reactor with optical quality windows. Secure the autoclave on an optical board in the glove box. Mount a laser-absorbing graphite screen behind the autoclave. To ensure temperature homogeneity, select focusing unit lenses to